Any, gosh, she's always there. Anybody have questions from any homework stuff or anything? Because you all remember there's a quiz today, right? I'm pretty sure there's a quiz today. Yes. Everybody remember that? Remember? All right, I'm going to take your silence as a yes. I see some people nodding their heads. I appreciate that. So if you have any questions on that, so remember it's section 8.1, section 8.2, which was reducing fractions with variable expressions in them. And also the question about like when is the bottom undefined? You know, like when's the fraction undefined, so when's the bottom 0? And then section 8.2 was multiplying and dividing two fractions, right? So you have to factor, 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 kill, kill, kill. If it's division, you got to flip it. And then factor, 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 kill, 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 right? I'm going to take that as a, yeah, all that's good. Okay, so any questions? Because everybody, of course, is doing that homework or approaching it, I guess. So this is for everybody that's behind on homework. And I've said this to a few people before already, but still, you leave old homework behind for the moment and you do the newest stuff. Because we got a quiz today on 8.1, 8.2. If you didn't do 8.1, 8.2 homework, you're probably not going to do very well in the quiz because you're not going to know what's going on. Now, extra on top of that with chapter 8 is if you don't know chapter 7, you can't do any of chapter 8. So this is one situation where I would say do chapter 7 homework, yes. So, because the more you understand factoring, the easier chapter 8 should be. Okay, enough of that. So nobody's got any questions apparently. So we are going to get right back in to where we left off. And I am going to talk slowly and say nothing as I attempt to pull up the textbook very, very quickly, which quickly is different than you would want it to be. Okay, here we go. So I want to pull up some examples of where we are. Kabam. Okay, okay. So the last thing we did, we got into section 8.6. And we did some examples of section 8.6. So let me see. What's interesting to me, the book has a different approach than I do for these problems. So if you look at the book, you could do it their way if it makes more sense to you. I do want to show you something that, let me see. Okay, let me show you this. Let's see who recognizes this. Some of you guys know this procedure, but you use it in the wrong place as somebody's car alarm goes off. I don't know if you guys can hear that. Thank God they stopped. All right, so what the hell am I talking about? God, I wish I knew. Something like this here. Does anyone know the shortcut that I can use just on this kind of problem? Okay, no? Okay, so.
I guess just find the same denominator and the numerator will be the answer.
Okay, so let's do that, which is not really the shortcut. We'll develop the shortcut, and I want you to, and I'm kind of happy that nobody seems to know it in a sense, because I'm going to show it to you. I'm going to show it to you that is a shortcut based on exactly the same method that we've used. So what's the LCD going to obviously be? What does this guy here need? What's he need?
21.
Well, the LCD is going to be 21. So what's the first dude need? He needs
3.
3. And the other guy needs
7.
7. And so you get 3x over 21 equals 14 over 21, right? And then what do we do? Since it's an equation, what can we do that we can't normally do? Why did we make the bottoms the same? Because now I can do what?
Multiply 21.
Multiply by it. Good. So multiply both sides by 21. And it cancels. Now notice this. What's it look like the 3 did? Doesn't it look like the 3 just went up there? What's it look like the 7 did? Doesn't it look like the 7 just went up there? That's the shortcut. Has anybody ever heard of cross multiplication? Cross multiplying. Has anyone ever heard of cross multiplying? I'm a little surprised if no one has ever heard of it.
I did this, but I just forgot.
Oh,
Yes,
that's okay. You might have forgotten the name of it. But do you notice you don't even have to know the shortcut to be
Yes.
able to do the problem? It's not really different. There just happens to be a shortcut if there's one fraction on one side and one fraction on the other side. That's the only time that shortcut works. It is a shortcut. So it has to only work in certain situations. And then, of course, to finish this out, do you see how I get here directly? If I do this, 3 goes up, 7 times 2. That's how the shortcut works. If you don't like the shortcut, you have a special place in my heart. I kind of love you. But if you like the shortcut, what the shit? I love you too, because I like getting things done quickly. But shortcuts are not necessarily. I like that. Let's try another one.
Answer.
Yes.
So how this works? How does this work?
We
So
see how it works.
why? Yeah.
So what?
Why this? Yeah.
All right, so let me explain this in a little bit different way. So now here's a little bit different way to do this. You ready? Okay. I can multiply both sides by 3, and that would cancel, right? I could then multiply both sides by 7, and that would cancel, right? So effectively, the 3 and the 7 go up. They don't just go up. We see what happens. We apply the process, and we notice a pattern, and we make a shortcut out of it. But we have to be really careful about what was it that made the shortcut work here. 1 fraction equals 1 fraction. That's the only time you could do cross multiplication. So, what if I had this? What you got, Jim? So the shortcut would say 5 times n is 5n. n plus 7 times 4. Make an equal sign, Jeff. That's the shortcut. That's the shortcut. The 5 times this, that's cross multiplication. You guys see why it's called that? Cross multiplication. Cross multiply. And then you just solve this really nice I don't even care what the answer is anymore. All that matters is the process. The right answer is nice. Okay, so to be honest, you don't need that shortcut if you don't want it. Because now watch, let me do this problem the old-fashioned way. I know, you might not be able to see this. Hold on. All right. What does this guy need that this guy has? Obviously a 5, right? You guys with me? Where's my other pen? This guy needs a 5. What does this guy need? That's right, kids. M plus 7, right? And then can't I multiply both sides by that so they'll cancel? Isn't that the same thing I got right there? Isn't that the exact same thing right there? Isn't that the same thing? Yeah, so you don't need the shortcut. I just want you to be aware that it exists. I think that you guys have seen it before. You might have just forgotten what it was called or what it looked like. But it's one of those shortcuts that are okay, but it's not really completely necessary. I'm sorry, I'm touching the table. It makes everything shaky. Oh, sorry. Okay, all right. So let's try a problem that we saw last time that I cannot use this shortcut on, right? Something like this here. Ooh, well, I don't know if I can think that far ahead. No, Jeff, no. Let's see. Um, oh, let's see. Okay, can you guys see all that? Yeah, you guys can see all that. So why won't the shortcut work here? Because it's one fraction equals 2. Shit, right? There are other ways to do this problem, but I'm going to keep it going the same way. So which one of these bottoms can I factor? Of course, I can factor this guy. Not surprisingly, this guy factors like that, right? So I told you before that there's very often a hint in some of these problems. So this is m minus 10, m plus 6. I'm going to rewrite it there, so I'm going to cross that out. So now you can see very easily what this guy is missing and what that guy is missing, right? Go ahead and keep going. Try to finish that problem out. I'll catch up to you. I need to get a refill on a drink. Dranky drank. Let's see. Where did I put it? Oh, yeah. Yeah, it's going to take too long, I think so. I think somebody just came in right when I walked away. We're doing this problem right now if you just came in. Or I mean, you're doing it. You do it. M 22. I think you get some fraction. Might be 22 over 8. I'm not sure. Trying to do this in my no. Oh well. I'm trying to do this in my head. So what's this guy need that everybody else has? This guy here. He's got an m minus 10, but what does everybody else have? Also. Do you guys understand what I mean when I say that? This guy's an m minus 10 and an m plus 6. This guy's got an m plus 6. So what's he missing?
M plus 6.
M plus 6, yeah. So what's so he gets that there and there. What's he missing?
M plus 10.
Huh?
M minus 10.
M minus 10. Okay, so let me see if you guys can handle this so I don't have to write all this again. Once you get all the bottoms the same, you multiply everybody by it. So it cancels here, and it cancels here, and it cancels there. All right, I know that's a lot going on there. But once you get all the bottoms the same, since it's an equation, you can multiply both sides by that bottom, so it cancels everywhere. That kicks so much ass. Now you just got to collect all the survivors. Only an m survived that side. I was there that day, and and then on this side I get 7m plus 42 plus 2m minus 20. Okay, let me stop. Do you guys see that? Distribute, distribute. That's what's there. The bottoms canceled, the bottoms canceled, the bottoms canceled. And now this is a very nice, it is, what is it? It is 22 over 8, isn't it? Yeah. Negative 22 over 8. All right. So then you get m equals 9m plus 22, subtract 9m, and then divide by negative 8. Just like that. Phew.
So, Professor,
Yes.
do we have to write this negative 11 over 4 or just leave this?
Yeah, you have to reduce it now. Good. I was waiting to see if anybody would, and you did. Great. So now this will be negative 11 over 4, because no matter what kind of problem it is, what's the last thing I do with fractional things? See if they reduce. I like it. Now, on top of that, can anyone tell me the two values of m that I could not accept? What would make this undefined if m was, what would make this 0 if m was, what do I subtract 10 from to get 0?
A minus 10.
No, 10.
It'd be positive 10, right?
Yes,
Yeah,
positive
yeah.
10. So m can't be positive 10, and m couldn't be
Negative 6.
negative 6. Did I get either one of those? No.
No.
So on that level, it seems that could be the answer. Did I just check this answer? No, I didn't. I just made sure it didn't make anybody undefined. If it did, I'd have to throw it out. Okay. Okay. I'm going to erase this.
I have
Yes.
a quick question.
Yes.
So basically, once you get it down to to a formula where you have to simplify, you just pretty much just simplify it down to what m equals, and that's it.
What I really want you guys to realize, this is an equation. We got rid of the denominators. It's still an equation, but now that we did that first step, we have made it become something that goes way back to chapter 2, I think. Right? So I think what you're saying, Curtis, is, I mean, once I do this first step, denominator's the same, and then kill them, I've got a really, really simple equation. I kind of forget about this shit for a minute because now I have to solve this equation. So I solve it like I always get the m's on one side, get the numbers on the other side, then divide. It's just the last thing I do is go back and say, oh yeah, it started off like this. I got to make sure that the answers I get don't freak the equation out. That's the only new thing. So maybe. Is that all right? Okay. All right, so let's try another one. Let's see. Let's try this one, yeah. Wait. Ha. Ooh, this is gonna be yummy. Ooh, I like it already. Ooh, I love it. It's so yummy and gross. It's yummy and gross. Ooh, it's a little worse than I wanted it to be. Let me think about this for a second. Well, let's see what happens. No, 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 no. I'm not going to be that lucky. Let me add one more thing in here. Okay, let's do this. That's a little less dangerous. It would probably become a problem we couldn't do if I didn't add that part in. I don't think I'd be lucky enough for it to be something we could handle. All right, now this looks sort of heinous, right? Or I don't know if you guys, does this look that much different than what we've been doing? Can you factor any of those bottoms? Yes, so that's always the first step on most of these problems in this chapter is there's a factorization step.
The
So
middle one?
Good. You can't factor this one, but you can factor that one. How would you factor this one?
Take an X out.
Good. Take an X out. What about this one? I can only go so far. Let me see. What can I do here?
Take 8 out.
Take an 8 out. All right. All right. So the only thing that I've added here, oh, sorry, I touched this here. Only thing that I've added here is there's a number. There's a couple numbers. Looking at the numbers, what would the LCD be for the numbers? I see a 4 and an 8.
8.
8. So they each need to have an 8 on the bottom, right? So let's do that first. What does this need to become 8 on the bottom? That's right, a 2. What do I need here to make an 8 on the bottom? It needs an 8, right? Is that cool? It needs an 8. And he's already got an 8. Now look at the variables. What is this first guy missing in terms of the variables that this guy has and that guy has?
X minus 1.
First guy. Sorry?
X minus 1.
X minus 1. So let me stop for a minute, please. Do you guys see what I'm doing? I'm only focusing on, okay, what makes the numbers the same on the bottom? Let me do that, and then they're all done. And then I can focus on the variables. This first guy's only got an X, and this guy's got an X and an X minus 1. That ain't fair. Give me an X minus 1. All right, all right. I'll give you an X minus 1. This guy is cool. He's got everything. And what's he missing?
X.
X. So I'm going to give it to him. Let me kind of squeeze it in there. Right, so I've just added that piece there. Okay. Let me stop for a minute. That looks really busy. Okay, so let me see what I can do here. Let me do this. Let me do a little bit more than I did on that last one. This is 18x minus 1, right? Minus, let me be careful over here. Hold on. This is more writing than I would normally do, but just to make it a little more clear, it gets really kind of busy if you don't rewrite it. Now I can multiply both sides by this. So if I multiply this side by this, it'll distribute to both. And I multiply this side by this. So that's completely legal. I can that's completely legal. Let me make sure that came out right. I can multiply both sides by whatever I want to. And in this case, if I multiply by that, all the bottoms disappear. There's no fraction left. And that's a beautiful place, right? That's what all of you wish for. I know it is. A land without fractions, Jeff. Can you bring us there? And I'm like, you can bring yourself there now if you have an equation. I can kill all the bottoms. Die. Die, bottoms. Die. So then I get 18x minus 18. And I should have done this, right? Negative 16x minus 8 equals 7x. So So now I'm just collecting all the survivors. Let me stop for a minute. I want you to realize it's still not a different problem. It's the same problem as the one we just did. Make all the bottoms the same. Multiply by that bottom, and then you just have the tops left. And it's a much nicer equation. Let me make that look more like a regular X. There we go. And now that's an easy equation. And in fact, no, too bad. It still doesn't come out nice. Too bad for you. But it's not going to be that ugly. It almost came out nice, but not quite. Oh well. Can you guys finish that? I mean, that's a beautiful equation. I think some students' brains cannot let go of this. And something that I can do because, I've been doing math forever, but also I think I was just lucky that I sort of looked at things this way. I know that this doesn't matter or shit anymore because this is what I'm working on. This is in the past. This is what it used to be. Here's what it is now. I don't have to worry about any of that until I'm finished solving it. Then I got to go back and make sure it doesn't freak anybody out, right? So here I get 2x minus 26 equals 7x, subtract 2x, and then divide by 5. I have no idea if you can see all that. No. Let's try to be a 5 down there. That's the best 5 I've ever drew in my whole life. So it's kind of nice. If you have an equation with fractions, you make all the denominators the same, because then you can multiply by that thing and make all the fractions die. And then you have just the tops left. And that comes out to be a nice equation. A really beautiful equation. Okay, all right. I'm gonna try to, well, let me see. I'm afraid to make the kind of problem we have to talk about because it could, if I just make it out of nowhere, it could get kind of gross. So let me, does the book have any like what I'm talking about? Maybe not. Maybe I shouldn't have to worry about it. Yes, it does. All right, let's try this one. Sweet. All right, here we go. So everybody got that? Anybody still copying that down? Okay. All right, so let's do this one. I like this. Where'd it go? There it is. Oh. Oh, shit. I like nobody saying anything. All right. There we go. This poor little letter. All right. So you should be able to identify where to start. So do the first step. All right, so everybody's done this now, right? Can anyone identify something wrong with the way things are written that would make me forget to do something? We did a problem like this yesterday. There's one of these numbers that aren't in the same form. So very often it's forgotten about. Are they all written like fractions? Each of the terms. What's 4 over? Yeah, who said that? Somebody said 4. Okay. So that's another bottom. That's a bottom. It's there. We chose not to write it. Doesn't mean it's not there. So I need to make all the bottoms the same. So what's this guy need?
X minus 6.
Y minus 6. Yes. So he needs a y minus 6. What's that guy need?
Both.
Both of them.
Y plus 6, y minus 6.
And can you guys handle this? This will make things a little better. If he needs both of these, isn't that this, right? Y squared minus, so I'm just going to put y squared minus 36 here. That makes it a little bit easier because now I just got to distribute the 4, right? So he needed one thing, he needs nothing. He needed both of these, which of course is y squared minus 36. So he needed both of them. So now I can multiply everything by y plus 6, y minus 6, y plus 6, y minus 6, y plus 6, y minus 6. That cancels with that. That cancels with that. That is the same as that, so it cancels. So what am I left with? All right, I'll do it. I'll do it. Mr. Waller, yes, I know. Okay. Y squared minus 6y equals 72 plus 4y squared. 4 times 36 is 144. I said it like that because I was doing it in my head as I was talking to you. All right, this one looks interesting. Do you guys notice what the big difference is? There's a reason I picked this problem specifically. There's a big difference between this problem and the ones we were doing before. What term do I have here that's going to mess things up a bit?
Squared term.
Squared. Yeah, Isa. Is your kid still around? Oh, gotta be careful. Gotta watch my mouth. I've got a power other than 1 on my y variable. I've got to make it all equal to 0 then, don't I? So let me first. So the thing is, you let go of where it came from. Let go of it. Now you've got that problem. Pretend like that's a brand new problem. I've got a squared terms in there. So eventually I've got to make this thing, what is this going to be? Minus 72. Is that cool? 72 minus 144 is negative 72. Now, do you guys follow why I'm going to do? Sorry, what?
Same, 72.
Yes, negative 72. I'm going to subtract y squared because that's going to keep my y squares positive and add 6y. Subtract y squared, add 6y. So I get 0 equals 3y squared plus 6y, become a y, minus 72. All right, let me stop for a minute. I think this is a huge problem students have. I treat each time I do something as if it's a brand new problem. So here I saw the square. So I knew I had to work towards getting a 0 on this side. Now I have this problem. What do I need to do on this side? Why did we make it equal to 0? What kind of weird people are we? What do I do on this side? What do I do on this side?
Factor them.
Factor it. I like it. Yes, yes. And be more specific. How should I factor it?
Correct.
Carefully. Sorry?
Minus 6y. factor minus 6y and like,
No. I need it to be equal to 0. I don't know if you're trying to move things to the other side.
Factorization.
Factor, okay, good. What do you always try first when you factor?
Oh,
Yeah.
just enough.
Because I don't know if anyone's out there thinking we had to do 3 times 72. Remember that? Do you want to do that?
No.
No, I don't want to do that either. Thankfully, a 3 comes out of all of these, right? So actually divide both sides by 3. So I get 0 equals y squared plus 2y. Oh, what the shit would that be? 24? Yeah. Doesn't that look much better? All right, do it then. Finish it up. Damn, I'm in class, dude. All right, let me catch up to you guys. So this is just a couple steps away from being done. How do you factor this? What's the numbers that'll work? Are there numbers that'll work? 2 numbers that multiply to be negative 24 add to be 2? Are you guys all right? Is anybody out there?
Here.
Hey.
Yes.
You guys are like, we're here. We just don't know what to tell you, man.
6 and 4.
6 and 4. And of course, the bigger one has to be positive. So then either y plus 6 is 0, which leads to y equals negative 6, or y minus 4 is 0. Add 4, you get y equals 4. Now, what's the last thing you got to check? Thankfully, here's finally a problem where something bad happens. Or not bad, but, you know. Where's that coming from?
Check the answers cannot be cannot make the denominator.
So what would make this, any of these, what would make these undefined? What would make this 0? And what would make this 0? Negative 6 and 6. Did we get either one of those?
Yes.
Oh shit, well you better throw that out. So the only answer is 4. So there's 2 possible answers. One of them makes the problem undefined. Throw it out. Can't use it. Get out of here. Your last step in these is always, do any of the numbers you got make this undefined? If so, you got to throw it out. Okay, maybe. Okay, so let me get rid of all this here. Anybody still copying this down? You guys all right? Okay. All right. All right. Oops. All right. So last one of these I want to do. Let me see if they have an example of this. Yeah. Okay, here we go. All right. You're going to love this. All right. You're going to love it. I know you're going to love it. And already you know you're going to hate it because of what I'm saying. Look at this thing. And I want you to solve for D. Why, Jeff? All right, so what is your immediate reaction to this? What is the worst part of this problem besides there's more letters than normal? What is the worst part of this problem?
Have a 3 variables. So the first one is what? 1 over what? F.
F.
Oh,
All right, so besides that, we have more letters than normal. What is terrible about this problem?
on the bottom.
They're all on the bottom. There's denominators. Do we have a way to kill the denominators? Can I kill the denominators? So can I make them all the same? Right? How do I make, what is this guy missing that these two have?
D and X.
Yeah, a D and an X. A D and an X. What is this guy missing?
F and an X.
F and an X. And of course, this guy's missing a D and an F. So then I can multiply by X, D, F, everything, and they all cancel out. So then I get dx plus fx equals df. Okay, let me stop for a minute. Oops. Maybe you're not the best marker to use. Thank you for your service. Okay. Come on, marker. Come on, marker. Nothing different there, right? Nothing different there from what we were just doing. Make all the bottoms the same, and then you can kill all the fractions. Now, what's the next bad thing? Do you guys see? Where's the D? I'm trying to solve for a D. Where is it? Is it in one place?
It's on two different sides of the equal sign.
But this is nothing new. If I'm trying to solve for X and it's in multiple places, what do I try to do? I try to get them all on one side, correct? So what's in the wrong place? Which piece is in the wrong place? What letter I'm trying to solve for? D. Which piece has a D in it that is in the wrong place? They're not together.
Minus df
No.
on
Nope.
the two sides. No.
This guy's in the wrong place, isn't he? I want all the D stuff on one side and everything else on the other side. He's good where he is. Let me subtract dx. Oh man, I can just feel it. You guys love this problem. So we got rid of the denominators the same way we have been. Then what do I always do to solve an equation? I get all my variable stuff on one side. All right, well, which one is the variable I want? D. So let me get all the stuff with D in it on one side. There they are. Everything else on the other side. Now here's the only thing that seems different. It looks like there's two D's, right? And now it's time for a little magic. There isn't two D's. There's one. So can I factor this?
Yes.
Yes, I can take this out. And then how do I solve for D? What do I need to get rid of?
X.
There's no X. What does this side say? D times F minus X. So which piece do I want to get rid of? I'm sorry, I think you just said it.
df, d multiplied f.
No, this is what we just came from. Didn't we just take the D out?
Minus.
You want to get rid of the F minus X.
Yes. Yes. This is D times shit I don't want. So how do I get rid of the shit I don't want? I divide by it. Is it D times this shit? I don't want that shit. So let me divide by it. Done. It's trying to be a D. Got a little bit too fancy. That one was way too exciting. I get that impression. I'm sorry. I need you to realize no step we just took is different from any step we ever do. It isn't. You guys don't trust me. So what if I had fx equals 5d and I'm trying to solve for d? What would I do? What's the next step to solve for d? What's the next step to solve for d? If this is what it was.
FD, 5D, divide 5D.
No. Divide by what?
5.
5. I'm trying to get
Five,
d by itself, right?
Okay. Oh, okay.
Divide by 5. So what if it was fx equals 10d? What would I do then?
Divide by 10.
Divide by 10. So this is fx equals f minus xd. What do? Divide by f minus x. So it cancels. The same exact reason. There's something times d. I don't want that something, so I divide by that something. Exactly what we would do if it was a number instead of a variable expression. I know it looks different. I know it does. But I really try to get you guys to realize it's not. It isn't any different than what we would have done before. But I know it looks very different. Okay. All right, so I want to do a little preview of what's coming, and then we'll stop. Yeah, it's about time. We only have one more chapter, a few more sections, and the final's quickly coming. I don't know if I told you guys there will be a practice final, right? And I'll have a practice final answer key, right? I don't know if I told you that already. But let's look at this real quick. What does this symbol mean here? This symbol like this.
That's
Divide?
division.
It's not division. No.
So
There's-
it's called square root or
Square root.
Square root, yeah.
It's called a square root or a square root square.
Square root.
Square root. Say
Square root. I like it. Sometimes I call it a root because I'm a Georgia boy. It's roots. And of course, does anybody know what the square root of 9 is? Anybody ever seen that before? What's the square root of 9?
3.
3. Good. Because what question does this symbol represent? So every math symbol represents a question. We just don't want to write the question every damn time. So we made a symbol. So this symbol means, what does it take 2 of to multiply to be this number inside? So it takes 2 3s. So that's why the answer is 3. So when you see me writing this symbol, say to yourself, what does it take 2 of to multiply to be this number he just wrote?
5.
5. It takes 2 5s to multiply to be 25.
5.
So what about this? Can you guys see that? Oh, my glare.
4.
All right, now watch. If you think the answer is -4, what's -4 times -4? What's -4 times -4?
16.
Yeah,
Not
positive.
-16.
Positive.
Positive
16.
16.
Sorry? Yeah, it comes out to be
Positive 16.
positive
Yeah,
16.
positive, yeah.
So are there 2 real, no, is there a real number times itself that comes out negative?
No.
Nope. No. So the square root cannot handle negative inputs, negative numbers inside, because there aren't 2 real numbers that multiply to be negative anything. Right? So that
we can do -8 times +2.
no, we can't.
No?
Because
We can.
again, what does the square root symbol mean? The square root symbol does not say factor this. The square root
Okay.
symbol says, what does it take 2 of to multiply to be the inside?
Okay.
3 times 3 is 9. 5 times 5 is 25. So what times itself is negative 16? There is no real number that does that.
Prime?
It's not
Yeah.
asking to factor it.
No? Okay.
So one thing you could think to write is no solution, but the answer is not real.
No, yeah.
Because there are numbers that aren't real numbers that make that work. And the word real is unfortunate. It is a bad choice of words, but historically it just stuck. This doesn't mean that the other numbers are made up. The word real is just a name they chose to describe the numbers we work with most of the time. Are we going to get into those other funky ass numbers? No. But when you see the square root of a negative number, you say not real. It's not something we know. It's outside of our knowing for the moment. Some of you guys might know about numbers called complex numbers, but if you don't know, even if you do know, you don't have to worry about it at this point. So last question of the day. What do you think this would mean? There's an understood 2 here, by the way. That's why it's a square root. So that 2 means what does it take 2 of to multiply by 9? So what do you think this question is saying?
I can see it.
Let me write it with better pen. So this one's asking, what does it take 3 of?
Cubed root.
Yeah, so what does it take 3 of to multiply to be 8? And we know this with cubes. We've done it with the difference of sum of cubes.
A
Say
number times 3 times.
something times itself 3 times becomes 8. What does it take 3 of to become 8?
2.
2. 2 times 2 times 2 is 8. So every root is about taking a number and breaking it up into parts. Square roots breaks it up into 2 parts. Cube roots breaks it up into 3 parts, which sounds a lot like different sum of cubes, right? Yes, it does. Okay, that's enough. That's enough for today. So that's just a little taste of the next chapter. So don't forget, right after this class, right after this lecture, I don't remember if I put it up yet. I'm going to make the quiz active on Canvas, so go get it and do it. Right? I think I put it up on Canvas, so I just have to make it published. But now that I think about it, I might not have. So you might want to give me a few minutes to get it up there.
Quiz for chapter 8.
Yes.
Section 8.1, section 8.2. So remember, I put that updated homework sheet up there. It's got all the dates for all the quizzes left. You definitely want to pay attention. I think there's one more after today. Okay.
Bye.
Anybody questions? Anybody need to hang out? Are you guys good?
Yes. Don't
Good.
forget the quiz makeup.
Oh,
Makeup.
yeah. You got to email me. Remind me. Yeah. Anything that's not, anything that's outside of the ordinary of the class that I need to be reminded about. Yeah. But not like this. You remind me right now, I'm going to forget about it.
Yeah.
Let me go make this current quiz active. I'll see you guys next week.
Bye.
Have a good weekend.